In this part of the lab, we will create a cooling curve for Salol.
Now, Salol is this solid we have here in this test tube, and you'll see that it has a pretty interesting cooling curve, and hopefully you might even see some supercooling. Anyway, that's what it looks like as a solid. We're going to put it into a warm water bath to melt it into a liquid, and then take it out and basically just make a note of the temperature as a function of time while it cools back into a solid. So keep an eye on it. Just we're going to draw again a graph just like we did before with our heating curve of water, except of course now the temperature should be dropping as a function of time. All right. Alrighty, here you can see that I have started cooling this down. I've melted the Salol into a liquid. It's a clear colorless liquid, as you can see. It's at about, let's see, about 55 degrees, so maybe a little bit above that, 56, and dropping. Feel free to speed up this video and every minute or so make a temperature reading from the thermometer on the left and plot that data. In this next part, we're going to determine the heat of fusion for ice experimentally by adding some room temperature water and making a note of the temperature change as the water cools down and the ice warms up. This is basically a heat transfer problem where we can calculate the heat that leaves the water that's cooling down using Q is equal to mc delta T, and we can then use that amount of heat in figuring out just how much heat was required to melt the ice. It's the same amount of heat, just with a negative sign in front of it because the heat is leaving the water, and it's going to be a positive value for the ice, which is gaining that heat. Anyway, we have here a styrofoam cup, and so to begin this part of the lab, we're going to determine what its mass is. So note that I've tailored the balance. And add our empty styrofoam cup in there. Okay. There we have the mass of our styrofoam cup. Now to that we're going to add our 100 milliliters of water. The actual volume isn't that important because we're going to figure out how much water is in there by using mass. So let's go ahead and make a note of the mass of our styrofoam cup with water in it. Okay, so there is our mass of the cup and water together. Okay, now in addition to this, we also have to figure out the temperature of the water. Because remember, in order to figure out the amount of heat being transferred here, we have to look at the change in temperature. So I'm going to add a thermometer here with another piece of styrofoam cup. This kind of helps insulate our apparatus here to stop any heat entering or leaving that might affect our results. So let's have a look at our temperature. See if that comes into focus. There we go. Let's try and avoid a parallax error on that. Here's a close-up of the temperature reading on our thermometer, so please make a note of that. Now that we've got the initial temperature of our water, we're going to add some ice to this water and keep track of it, and hopefully we'll drop the temperature down to about 2 or 3 degrees Celsius. So let's go ahead and do that right now. The ice. There you go. You can see the temperature starting to drop. Hopefully that ice will continue melting. Now, the thing to watch out for here is that if we get down to the temperature we want, we have to hope that all the ice is melted, but if it's not, we can do a quick transfer of the water to another container while we dump out any excess ice. The key thing is we don't want any ice in our beaker or in our styrofoam cup when we weigh this at the end of the lab. Looks like we're down to about 7 degrees or so. Let's have a peek in here and see if we still see some ice in there. Yeah, it's still a little bit of ice, so hopefully that'll melt a little bit as I stir it. It doesn't look like we have any ice left. Oh, maybe a tiny little bit. It's kind of hard to see because it's getting a little translucent. Let's see. Hopefully it will drop down. I might add another cube just to get the temperature down a little bit more. And let's add one more cube of ice, because why not? One little cube. Oops, let's set that down so I can use both hands. Hoping that by stirring this, I'm getting the warmer water and the cooler ice to mix a little bit better. You want to be careful not to stir too vigorously because you don't want to generate any friction. That also is a source of heat and that can mess with your results a little bit. Again, you're stirring gently enough that I think it should be okay. Let's see if our ice cube's melted. Nope, I think I still see it in there. Alrighty, we're getting to about the temperature we want, so as soon as we know that our ice is all melted, looks like there's still a cube in there. I guess it's hard for you guys to see with me angling that webcam wrong. There we go, hopefully. Yeah, it's a little hard to see in here because just because it's a little dim inside the styrofoam cup, and the ice cubes as they get thinner and smaller, they get a little bit translucent, so it's hard to see. But right now I can't hear any clinking from the thermometer, so I think that should mean that all the ice is melted. So let's make a note of that final temperature on our thermometer. Take a close up with my phone here and get a nice good temperature reading on that. So let's make a note of that final temperature. Okay. All right, now that we've gotten back to our final temperature, let's take out our thermometer. And let's make sure we don't have any drops of water sticking to that. Set that down. And let's get a final mass reading for our water and our styrofoam cup. So you can see it's already zeroed before I had it in there. Alrighty, and that's our final mass for our styrofoam cup, the water we started with, and the ice that melted. So make a note of that. Okay, based on that, you should be able to figure out how much ice melted and how much, from the temperature change, figure out how much heat went into warming up the water, cooling down the water, and realize that same amount of heat went into melting the ice.